I'm Zach Taylor. I'm the team lead for our Azure practice at Adastra. I work with our managing director, Kevin Harmer, to make sure that the consultants we place have the right tools and are preparing for the right advancements in cloud technology. For the purposes of this webinar, audio is disabled for attendees. You can ask questions through the toolbar to connect to the panelists directly through the chat function. We'll address all the questions at the end of the presentation. Adastra is Microsoft's #1 partner for data and AI-driven digital transformation, and we are Microsoft's 2019 Enterprise Partner of the Year in Canada. Adastra has worked closely with Microsoft to help guide the development of Synapse through private preview collaboration and have proven the differentiating values to the market through end-to-end analytic implementation across industries. Through 50+ modern data warehouse implementations and 10+ Synapse Analytics implementations, we have developed a set of best practices, accelerators, and institute a system of excellence for the Azure ecosystem. We focus on delivering end-to-end analytic ecosystems that help organizations achieve digital transformation. Now, let's talk about how the world of data has changed. First of all businesses are now data businesses. From the corner store with an online accounting system and stock keeping to the largest internet retailers, we all run on data. And an enterprise that does not manage, govern, and secure its data will simply not survive in this new economy. It's one thing to gather and manage data, but it's another to make decisions based on it. This is where analytics comes in. Without analytics, data does not serve any roles. We need dashboards and reports that support the awareness of the current state of the business. We need BI and visualization that strengthen the role of knowledge workers with informed insight. And we need augmented AI that can discover information and patterns that even experts may overlook. Analytics is important, but it's increasingly evident that not all analytics are created equal. Businesses can do more and more complex analytics for better, faster, and more automated insights. Data science enables automated insights with a depth and scale beyond even the best of the human analysts. Even small businesses today need scalable analytics to deal with social media, digital interactions, and marketplaces. Increasingly, machine learning and artificial intelligence drive autonomous processes and decisions for agile organizations. Now let's describe how data warehouse serves a business through a simplified architectural diagram. The modern data warehouse sits at the heart of enterprise analytics and as a source of sanctioned data, as a system of record, and as a hub serving for modeling of reporting, business intelligence, and data science. It is a data source for analytics. It provides an enterprise system of record for business processes. The data warehouse is mostly built over line of business data sources, your transactional systems. Whether that data is unstructured, structured, or semi-structured, modern data warehouse architecture can handle it. Other, more volatile sources are often used for data science or for ad hoc analysis with big data systems. For data warehouse, Azure Data Factory schedules and orchestrates data transformations and bulk loads. Meanwhile, Azure Databricks can perform transformations specifically for data science and also build and execute models. Scores from these models may be loaded into the data warehouse to integrate these insights with enterprise applications and reports. The Azure Data Lake may also be used to store raw data in high volume for later use, along with staging transformed and cleansed data after processing through a Spark engine such as Azure Databricks. The Azure Synapse Analytics provides high performance, highly scalable data storage for enterprise models with outstanding security, governance, and manageability. At the very end, We have Power BI, which consumes sanctioned enterprise data from the data warehouse for reporting and analytics, but may also use data from the data lake for ad hoc analysis and for integrating with data science. Many business services include line of business applications, consume data from the data warehouse as an authoritative, governed enterprise knowledge base. Understanding your data is only one piece of the puzzle in today's world. Being able to articulate your data's insights to your organization is where the real value is found. Increasingly, decision makers reach beyond traditional reports and dashboards to engage with new sources and tools, traditionally big data, machine learning, and even AI reports. In this environment, being able to define and work with the data-driven processes is essential. Data literacy has become more than just a useful individual skill, but is now a shared organizational practice. When shared data literacy can be combined with self-service tools, individuals become empowered, teams become tighter, and organizations become stronger. Business users today are tech smart, expect tools and services that work the way they work. Just like BYOD, users expect their self-service analytic tools to build their own dashboards and visualizations. In an enterprise with self-service analytics, IT cannot expect to control and constrain every aspect of knowledge work anymore, but they can provision data and services while monitoring usage and security. Self-service business intelligence, Citizen BI, puts data governance in the hands of all users. IT's new role under this format is to provide well-managed tools and services to support effective best practices, even if we cannot guarantee the results. Services include curated data for business users to consume for BI and analytics, and platforms which include data warehouse and data lakes with data science tools and self-service analytics. New business capabilities are enabled not by data alone, but by data models which describe concepts, relationships, rules, and standards. Enterprise models consolidate data from many sources for analysis. Business intelligence models, BI models, use enterprise models but focus on a single subject area in more detail. And machine learning models are developed from raw sources and are often experimental and require a specialty skill set for production use. We use models for consistency. There are numerous business processes that should be built once, defined once, and shared as a corporate standard. These are things such as defining your product catalog, your staff hierarchy, and your client organization. We also use models for governance. Certain data sets, such as customer information or financial, need security and privacy controls, which may be complex and dynamic. We use models for efficiency. If models already exist in the data warehouse, there is no need to reinvent the wheel and repeat the work of the design, preparing and loading data, or securing the model. We do use models for flexibility, as there are a number of data sets which are temporary or external or ad hoc and are unlikely to be consolidated into the data warehouse proper. In these cases, BI models are useful, for example, for planning and monitoring a short-term campaign or modeling a budget for a departmental project. We also use models for efficiency. Tech-smart business users have fresh and innovative ideas which they need to explore with agility. The process of building centralized models to support all these initiatives is too cumbersome, but the successful and widely adopted business intelligence models may be refactored into the data warehouse for future use and avoiding a quagmire of access databases. The cloud enables projects that are easier to start and easier to scale. ERP, CRM, and operational applications are increasingly becoming cloud native. Collaboration platforms and file sharing have transformed the cloud's flexibility and scale. And even when governance requires on-premise data management, a modern business tends to be of a hybrid nature. Cloud-based data warehouses services provide layers of protection, built-in security, and compliance tools. In the data warehouse itself, you expect to find encryption, sensitive data classification, and row and column-based security. But you'll also need services such as threat detection and monitoring, security through a virtual network, and integrated ID management. Resilience and availability are not just good objectives, but in a cloud environment, they are vital security features in a global always-on services. Geo-replication, point-in-time restores, and high availability come baked in with cloud-native PaaS offerings. Cloud-based data warehouses eliminate the need for large CapEx investments. Deploying your data warehouse in the cloud is faster, it's easier, and it's more flexible than a traditional data solution without the need for high-end hardware and infrastructure costs. Iterating designs and handling diverse data is far more efficient in a cloud environment than on an on-premise solution. World-class performance is available to all users through the Azure Synapse Analytics, which optimizes analytical and operational workloads with elastic scaling. Now, Power BI is the market-leading platform and offers incredible capabilities when tied in with Azure Synapse Analytics for the highest performance cloud BW and reporting solution. BDW query performance is no longer a matter for just IT. Today's leading tools like Power BI can analyze and visualize large volumes of data. Self-service user queries are often exploratory and ad hoc and are not scheduled. Power BI users wishing to analyze real-time or unstructured data need a scalable platform which can be queried easily with familiar syntax and connectivity. This is where Azure Synapse Analytics comes in. The Azure Synapse Analytics is the continuation of the Azure SQL data warehouse. It adds in a Spark engine, on-demand pool and computational workloads, and an integrated workbench bringing together a variety of tools that were already being used in a modern data warehouse estate. We're looking at a diagram that describes the data warehouse, and the modern data warehouse, the Azure Synapse Analytics, sits at the heart of the enterprise analytics as a source of sanctioned data, as a system of record, and as a hub, serving models for reporting, business intelligence, data science. With Synapse, we have multiple innovations, including we can do multiple compute pools over common shared data, which provides workload isolation, predictable performance for different teams within an enterprise. Transactional consistency of data is guaranteed, and we avoid the creation of data silos. 2, we have online scaling, providing Synapse the ability to adjust compute resources allocated to a workload in real time without the need for any interruption to running queries. 3, we have a new cloud scale distributed query processor that dynamically assigns resources to maximize query throughput and automatically rebalance compute as workload characteristics change. We have a single experience for both data warehouse and the data lake. We can manage, monitor, and secure through a single platform experience. We have a one-click choice of SQL or Spark runtime within a single service that enables any analytics of all data in one place. Second, or last but not least, we have cluster and serverless form factors to provide a flexible compute allocation to suit the analytical workload needs. Now, with security, we have multiple levels of security between the user and the data warehouse. This keeps your data safe and secure. While some of our competition charges for different levels of security, Azure doesn't. They offer one comprehensive security plan, all at no additional cost. Let's dive a little deeper into these features and see how they keep your data safe and secure. So first off, at the higher level, we have a threat protection monitoring that provides, you get notified of any potential threats with auditing tools and anomalous activity alerting. We can leverage network security to ensure that all data is within the secured environment. We have a centrally managed and identity control through Azure Active Directory. We have row and column level security that provides granular access control. And your data is protected at rest, in transit, and well in use. Focusing on access control for a second, Azure Synapse Analytics provides fine-grained access to control with that platform. With the combination of native row level and column level security, you can ensure that data is secured for each user based on access. Dynamic data masking enables administrators and data developers to control access to their company's data, allowing sensitive data to be safe and restricted. It prevents unauthorized access of private data by securing the data on the fly. Because your data warehouse can store your most important and valuable business data, you should never compromise on security features. Azure Synapse is recognized as the industry leader in security. When it comes to data warehouses, and especially with parallel processing engines, concurrency is an important ask for many customers. In a nutshell, it indicates the number of simultaneous users or queries that can be run at the same time. The Azure Synapse Analytics engine leads the industry in concurrency with up to 128 concurrent queries for a single data warehouse. Concurrency can be increased with the increase in compute power. So by adding more compute power, we allow more users access to the data concurrently. There are preset functions in Azure Synapse that allow users to set concurrency limits so that you can divert resources from some users to more important workloads. The Azure Synapse Analytics has deep and tight integration with existing tools such as SQL Server Management Studio, SQL Server Data Tools in Visual Studio, Visual Studio 2019, the Azure Data Studio, VS Code, Command Line, and PowerShell. In a case of a major retailers, they've long embraced the concept of just-in-time inventory control. The on-premise point of sales capture transactions as they're scanned at checkout. Additional on-premise data stores typically contain information about vendors, shipping schedules, and existing warehouse inventory. As POS data reports the decreasing inventory on the store shelf, systems send automatic reorder instructions to the vendors who then arrange for delivery to restock the stores. While this churn would have worked well in the past, consumer purchasing patterns are changing based on increased use of the internet and social media. To avoid empty shelves from unexpected bursts of purchase activity, we can enhance our inventory controls to better determine reorder points and deliveries. Today's modern solution for POS and other on-premise data is to bring it into an Azure data warehouse. The data warehouse pushes the data through analysis tools, usually in 3 separate streams. One of those streams uses Microsoft Power BI to draw from models cached in an Azure analysis service that defines streamlined data sets, enabling near instantaneous, highly visual activity and sales reports that work well on mobile devices, for instance. Another data stream uses embedded Power BI to directly query the POS and other on-premise data systems. Vendors are then able to monitor the resulting dashboards in an inventory control portal and can immediately reorder inventory as needed. A third stream can extract data directly to the Azure SQL data warehouse and push it to Power BI to deliver real-time insights to top corporate decision makers. The data warehouse and support services can be enabled to handle all data collection and processing and transformation in one location more economically by using Azure Analysis Services to create the cached-in-memory models that showcase specific sales activity, including sales activity based on time, location, and ongoing product discounts. The big retailer can improve customer experience and reduce the likelihood of running it empty. You can reduce costs in this particular case by simply pausing the Azure Analysis Services when not needed. So we want to take a moment to review some of the functionality that was just published from private preview to general public preview. We're looking at the dashboard for the Azure Synapse Studio. This is very familiar to anyone who's used the Azure Data Factory in the past, and it combines a variety of different areas. Azure Synapse Studio likes to call these activity hubs. We have an activity hub for data that allows you to view structured, unstructured, semi-structured data in your data lake, in storage accounts, in your SQL databases, or yes, your SQL database. The develop allows you a single spot to write SQL code or Spark code, or C# or Scala in PySpark as well. While the Orchestrate Activity Hub focuses on pipelines similar to Data Factory for the large-scale orchestration of ETL or ELT design patterns. The Monitor and Manage Activity Hubs focus on the monitoring of jobs, both ETL as well as Spark and SQL results. And the Manage allows you to set up the connection points, formerly known as linked services, to a variety of different storage accounts, data sources, data syncs. So the orchestration panel provides the same series of a wide range of sources for the Azure Synapse engine. This includes both cloud-based, and it doesn't have to be Azure. We've also got ones for Redshift is available. We also have on-prem systems. We have access to Salesforce and SAP targets as well. So we can write our, in this particular case, we're looking at Spark code. So or SQL code. So we can write our SQL statements here. We can even use Polybase to query data that's on a storage. We can also use linked services or linked servers, just as you could on-prem. So using the OpenROSec command in this case. We are able to actually monitor the resource set as well as view Spark code. So we're able to visualize our Spark code not just as a chart, but we can change it into a graph right there and then, and we can export it as a Zeppelin or Javelin notebook. The notebook for Apache Spark engines, or for the Spark engine, allows you to do inline job monitoring. You can have multiple languages within a single notebook with the use of magic words. So you can have a PySpark notebook that can switch over to Scala, that can switch over to R or .NET as required, along with WYSIWYG documentation, as well as general Markdown style documentation. We go PySpark, Spark, .NET. And, oh yes, and the interactive Spark SQL as well. So BI is more than just simple reporting and dashboards. We've had reports, dashboards, but Synapse will allow you afterwards to grow into self-serve analytics, to develop predictive analytics and machine learning models, into what we now describe as prescriptive analytics, where it's not just enough to recognize changes in a trend, but how to react to those changes in the trend. So retailers are searching for ways to level up this data. So if we dive deep into this, we know that BI customers have been investing in answers for years. We understand that BI is increasingly becoming important to customers and to understand their data and bringing their data together, and primarily in order to gain insights into their customer base or how companies can improve. This has been done over the years by creating dashboards, which are focused on providing an overarching view of how different silos are going, such as sales, marketing, marketing campaigns, or other initiatives are performing. We also have improvements in ad hoc reporting when businesses need to dive into their data and find answers quickly and efficiently that weren't needed before. Or we see investment in creating advanced visualizations to illustrate the story that the data is telling and how to consume it. However, as BI customers have continued to invest in answers for so long, their data remains siloed, underutilized, and slow to provide the insights that they need when required. This is why BI customers need an industry-leading cloud data warehouse. It allows them to unify all their data in one source, regardless if it's structured, semi-structured, or unstructured. It allows them to have a single source of the truth. It allows them to extract instant insights on the fly with unmatched compute power and query performance. We can help customers combine their BI tools with Azure Synapse Analytics in particular and help open up new possibilities. For instance, we can now explore petabyte-scale analytics, where customers can reason and analyze over 1 trillion rows of data and discover insight in seconds instead of hours. We can provide insight for all, which means that data is no longer siloed, no longer difficult to access, or a hassle to share and collaborate on. One source of the truth, where your data resides, means that dashboards created in, say, Power BI pulls from the company's data, and everyone, from executives to business analysts to architects, can quickly get access to the insights they need, and that spans across their business. Synapse also allows for advanced analytics and AI, as customers step from going with just reactive reporting and creating static dashboards with their current BI tools to creating a data warehouse for their single source of truth. It enables them to use the data warehouse for the serving layer of AI information, and to begin going from just basic reporting to real-time reporting to predictive analytics and machine learning models. Having everything in one particular area means that data analysts, business analysts, and anyone using BI tools to build important reports to deliver insights shouldn't have to be impeded by slow query performance or low concurrency. With Power BI and Synapse Analytics, complex queries that take other systems minutes to be executed can be done within seconds. This is the speed that customers need to capitalize on their digital transformations, rather than being met with more roadblocks as they try to deliver on the promise of insights with BI. Sounds great, but collaboration is extremely challenging by design, and enterprises are plagued by data silos, access databases, that one crystal report, and incompatible tooling. There's lots of complexity when it comes to interoperating over siloed data. Plus, an additional layer of complexity when it comes to integration between the various tools and platforms that exist across an organization. So how do we fully harness data in today's world? Well, one, you need a powerful visualization and reporting engine to put insights into the hands of those who need it. Two, it's not uncommon for companies to have petabytes of data across the organization today. You need to power your dashboards with analytics that can handle this type of scale in order to quickly reason such massive amounts of data. Otherwise, running a query could take hours or even days in some cases. With advancements in AI, opportunities to drive even deeper insights have emerged. Successful organizations nowadays are leveraging AI all over the place, from monitoring tire pressure to knowing where to send their road crews to fix backwoods logging, for instance. So with all of this, we are able to consume the Azure Data Factory. We're able to access the Azure Data Lake storage. We're able to interact with the Azure Databricks. We're able to interact with the Power BI, and we'll show you some of the neat features that are coming up with that. And all of this in a single place in the heart of what is traditionally the analytics modern data warehouse. So Power BI and Azure Data Services unlock big data in a way that would otherwise be impossible. As we've mentioned, it's not uncommon for companies today to have petabytes of data across the organization. Analyzing and extracting insights from such massive amounts of data used to take hours, if not days. For the easier, higher level stuff, we can look at the common data model, which can be stored on the Azure Data Lake. This is a feature that scales and governs efficiently. It's all based on semantic modeling. It can improve management, and it's open platform connectivity, meaning not just Power BI, but Power Apps can also interact with it. So if we add in Azure Synapse Analytics using direct query, you can take data that would otherwise be impossible to use in a big data situation. So if we have petabytes of data that used to take, extracting insights from used to take hours, if not days, we can use Azure Synapse Analytics direct query to take advantage of the Azure Synapse Analytics performance for Power BI without concurrency limits. The new aggregation feature in Power BI boosts performance even further by caching data at the aggregated level, enabling instant response times on petabyte scale data sets with trillions of rows. If the user happens to drill down to a more detailed level, then Power BI can submit a direct query as normal and invoking the Azure Synapse Analytics lightning fast query performance to achieve something about 14 times as faster as other cloud providers. So together, Power BI and Azure Synapse give users the performance they need to do the aggregation and to drill down using petabyte scale data sets. Finally, Power BI and Azure help organizations unlock deeper insights with advanced analytics and artificial intelligence. When it comes to AI, Power BI comes with automated machine learning, which allows business analysts to train commonly used machine learning models without writing a single line of code. More difficult business problems that call for advanced methods require a specialized data science tools. The Azure Machine Learning Studio is a platform where data science can develop machine learning models to take on complex business challenges. Data scientists can easily use data in the data lake to train models in Azure ML. This has the Machine Learning Studio has a load of productivity enhancing capabilities that can reduce time to insight from weeks into hours. Now, the machine learning models built by data scientists can easily be shared with business analysts. Power BI has behind-the-scenes capability to discover which models each user has access to. It can automatically create a point-and-click user interface to invoke them. This makes collaboration among the data scientists in the business analyst community easier and faster than ever before. You want to take this chance to look at some of the preview functions for Azure Synapse and Power BI. So one of the preview functions is that you can actually start working on Power BI reports in the Azure Synapse workspace directly. You can also access published reports in the Azure Synapse workspace. You can update the reports in real time by publishing them directly from the Azure Synapse workspace. So you can actually view the reports they generate as they would on a web interface. You can edit them. This is the same layout as the Power BI desktop authoring tool. And you can publish your changes simply by saving the report. And this will publish the report to the workspace. This is not directly publishing from the workspace to the Power BI app, though. The end result is from the web, you have your changes already automatically published to the workspace. And when you're ready, you can publish that within the Power BI app. So getting started with Azure Synapse and Adastra. Adastra has worked closely with Microsoft to help guide the development of Synapse through its private preview time through collaboration, and has provided differentiating value to the market through end-to-end analytic implementations across industries. We've mentioned that we've worked on at least 50 modern data warehouse implementations and have added over 10 Synapse Analytics implementations in the past couple of years. We have developed a set of best practices, accelerators, and instituted a standard of excellence for the Azure ecosystem. We have a couple of offers out there on the marketplace now. You can contact Adastra and Microsoft to qualify for free Azure Analytics hands-on training. We have a free half-day discovery session, and we also have a more in-depth roadmap assessment to help plan your journey to the cloud for MDW workloads. At this point, I want to thank you for your time and open it up to any questions.